Hey there, welcome back. I'm Chris, and today we're going to work on a new embedded project. Basically, I want to go through a real simple embedded project, and we'll go from concept all the way through to building at least a prototype. What I want to build is a device that allows us to play a training game for Olympic fencing, for saber fencing. It's really simple. You don't have to know about fencing, but it kind of gives you at least a little bit of concept as to what we're building. So let's take a look on paper what it is that we're going to design. All right, so let's imagine that we have a target. We'll just call this a saber mask. Now these are electrically conductive, and it's going to be kind of in the middle of a strip. And then we're going to have two people, one on either side, facing it, and they're going to have a saber. And then when the referee says fence, they're both going to rush forward and touch this. And what we want to do is whoever touches it first gets a point. That's all there is to it. Real simple. So electrically, what I want to do, since this is conductive, we're just going to tie this to probably like 5 volts. And then these we will tie to ground. So when we connect this line here, if we're watching this line with our microcontroller, it's going to look like this. It's going to be high, and then as soon as somebody touches it, it's going to go low for some period of time and then come back high. We want to look for this falling edge interrupt right here. So really that's all there is we just need to wire up a target which is conductive, pulled high, and then we're going to do this. Now, we don't want this ground to, short things out, so we'll probably put a resistor in here, something like a 10K. I'll decide either through a little bit of calculation or just, through trial and error what the best value, but somewhere around that, so that we're not doing a direct short. But otherwise, that's all we need. And in fact, I think we can probably use a pull-up resistor on the microcontroller for this. Going to build this with a Meadow. This is an F7 Feather. It's got a whole bunch of I/O on it. The primary reason that I'm going to use this is because we've got libraries for a whole bunch of stuff already done. So it should be really easy to put this together. All right, so let's take a look at some basic requirements for what it is that we're building. First, we're going to have, obviously, one target, 2 sabers, but we're going to have these 2 sabers for inputs. We want to have a way for it to keep and display score, so we need a display. We need some way to show when a touch has happened. So we want to display the score, touch display. We probably want something so that if you accidentally touch it or for some reason we want to nullify or it didn't count a touch, we want to add manual plus or minus for the scores, right? We probably want some sort of a reset to bring them back both to 0. How about a piezo for a little bit of audio? And, what the heck? Let's go with battery operated as well. So these are some good basic requirements. In the future, though, maybe we want to add some things like a REST server for Wi-Fi, and then you could use your phone or a tablet for dealing with scores and looking at things, whatever. People could have all sorts of fun adding to this or expanding it, but this is really what we're going to do for our basic needs. As I said, we'll use a Meadow F7 for the controller. For a display, I actually like this 7219. We can turn on pixels to give some sort of a display for the score, but what's important is these come in specific colors, so the whole cube is one color. Now in fencing, we've got red and green are the two. So what I did was I built this We've got a pair of reds, a pair of greens, and we can turn on any of them or individuals. So the idea is we can light up a whole block for touch right or both of these for touch left, and we can put in the score here and here for the score for right and left. So we'll use this for the display. We'll use this for all of our logic. I'll probably add some buttons. I'll find something cheap off of Amazon or eBay or somewhere. See if I have anything, maybe even locally, for our score, up, down, those types of things. So let's take a look at just a quick block diagram of what this might look like from a wiring perspective, right? So we're going to have our microcontroller, again, the Meadow F7. We're going to have, let's put in a switch here to the battery so we can turn it on and off. We're going to have our display, and the 7219 is connected over SPI. Let's see, we're going to have inputs for reset, left, let's go plus for up, score, left minus, right up, right minus. So we need 5 inputs for buttons. And if we actually take all of these and connect them to ground internally, we can just do a pull up on those. So we don't need really anything other than just a simple wire from here back to our positive. So these all will just go like this. Super, super simple. Then we wanted, this is our VCC, so this is 3 or 5 volts. It's a 5 volt tolerant part, so we could use either one. But this will go out to our target. It's the mask here. And then we just need a couple of inputs for saber left and saber right. So really we've got these 2 inputs and these 5 inputs. We want them all to be interrupt based if possible, because I'd like to not have to pull for these buttons and it'll be faster. So effectively we just need the SPI and 7 interrupt capable inputs. I'm not going to go over all of the code, every line in detail. We're just going to kind of go through my thought process and how I've laid this out. The full source, it's open source. It is available in the Yoshimoshi repository up on GitHub. I'll put a link down in the description. You can go take a look, pull all of this and try it out yourself. But at least let's take a look at the highlights of my thinking when I put this together. First, I've got a hardware configuration that we can pass in. This takes these digital interrupt port interfaces and a game display. Again, we needed 7 inputs. That's what these 7 are. The game display, I created an interface for. And basically, we want to be able to show 3 things. Either show the score or show when somebody is touched left or right. This will make a little bit more sense here when we take a look at the game itself. So if we think about how this game will work, there are really 4 states it can be in. Either we're in a state where we need to update the scores that are being displayed, or it is waiting for a touch. That's the idle state when it's doing nothing. This is the state that it will be in most often. When it has been touched, so right when someone strikes it, and then what I'm calling a post-touch, which is a period after the touches happen before it goes back to the score again. We want to be able to display that a touch has occurred and show who got the touch for, a few seconds. And then it will go back. So really what happens is we'll start up, we'll go into this score update to show it's 0, 0. Then it waits for a touch. When a touch happens, It displays who got the touch and sits in post-touch for a little while, updates the score, goes back to score update, and then goes back to waiting for touch. So really, it is these 4 discrete states, and when you have discrete states like this, it's a perfect time to use something called a state machine. So I've got a game class here, and we have a state machine that is just a background thread that is constantly running. Really what's happening is we just are in a while true loop, so it's always going to run. This is just some debugging information here. So when it is in the score update, it says, oh, okay, go to the display and tell the display to show the score, and then it goes into waiting for touch. At the end of this switch statement, we just sleep for a poll period, and I've got it set at 200 milliseconds, but that can be adjusted. We'll see how it goes when we actually use it to see if it needs to be any faster or if it can be slower, but it's probably a good starting period. Remember, we're interrupt based, so that is not how long it will take for it to register a touch. That's simply how often we look for a state change to know if we need to display something different on the display. While we're sitting waiting for a touch, you can see at the beginning I wired up all of these interrupts. And so when we get, let's look at one of these contacts. So if it's, say, the left, the right looks just the same. So if we're waiting for a touch, so we don't want it to allow you to score outside of waiting for touch. If we're waiting for a touch and you get an interrupt, on the left saber contact, the score left goes up, and we say that it was a touch for the left, and we change the state to touched. So the state down here goes to touched, and this is where it reads that current touch state that we just set right here. And so it decides whether or not it needs to display whether the left or the right are the one that scored. Then it changes the state again to post-touch, and it fires up this background task that will just wait for a delay. And that post-touch delay is 3 seconds. So that's how long will it show who got the score before it resets back to displaying the score and waiting for a touch again. So then after we wait that, it's going to go back into update. And so it's in the post-touch until this updates, and then it goes back to the update score. So what it'll do is it sits here in this post-touch doing nothing, waiting for this timer to elapse. When it goes to score update will go back to the beginning, and it will show the score with the new score, and then wait for touch again. So really, really simple. There's some other logic in here for all of the other, I guess, 7 buttons, 6 buttons, whatever it was. So we've got, if you want to manually add or subtract points from somebody, left up. We can only do this while it's in the state where it's waiting for a touch. It just updates the score for the left person and then changes the state back to score update, which will again change the display. Really simple. So we've got the same for left, right, up and down. Reset just sets both left and right to 0. And that's all there is to it. That's the entire game logic. So then the display, why did I do this as an interface? Well, the reason here is that I wanted to be able to test and develop all of this game logic without having to hook it up to a microcontroller and make sure all of that stuff was working. So I actually created a desktop version of the game. And this is actually a Meadow desktop app, and I'll show you why that is here in just a bit. But what I did was I just created a display implementation for the console that simply says what the score is or if there's touch left or touch right. not worrying about any of the logic for drawing, how to turn on LEDs, none of that. I want to just test the game logic. And so all of that works. And in order to do these interrupts, these digital interrupt ports on the desktop, what I did was, again, I used a Meadow desktop application. So it's a Meadow app for Windows. And then I used our keyboard driver. The keyboard driver is available in Meadow Foundation. It's for a standard 108 key keyboard, and it turns each key into a digital interrupt port. So I can actually just create a digital interrupt pin. So I can take those and I can create, for example, the left and the right saber. I can simulate those touching the target by simply creating an interrupt port on the left and right, which is the left and right arrow keys on the keyboard. And I did the same thing for the score up, down, and resets. These are the Q, A, W, S, and D over on the left upper corner of the keyboard. And then I just add this display to the game config. And so now it's using the keyboard for this game, and I can just run this. And it will come up with this. And you can see the game, when it starts up, it was in score update, it's 0-0, and it's waiting for a touch. Now, at this point, I can push the left arrow, which will give us an interrupt. And it says, we've got a touch left. The state has changed. There's some debug information in here for this. And then the display says touch left. So we've got this touch left. So you can see the game state is progressing through this. And then it goes back. It sits at score update for 3 seconds. We'll take a look again here. I'll trigger a right touch. But the score has gone up. So let me do a to the right. You can see we've got this post-touch 3-second delay, and now we're up to 1-1. We can test these other ones. So if I use the Q, score goes up immediately. Q again. Now I can bring that left score down with an A, back down to 2, back down to 1, back down to 0. I can do the same thing for the right, and I can just use D and that will reset all of them. So we've got all of that working. So I use this to develop the full game logic. The reality is, because of the speed of this, because I had the keyboard driver already existed, the display driver I had to write, but that was trivial. It's just going out to a console. All of this stuff, I was actually able to build this entire game in maybe 2 hours. It was not very long. And so I've got all of this working, and I did it with the desktop. I haven't even touched the microcontroller yet. What this means is I can set breakpoints, go through this really, really quick. I hit F5, and it's running almost immediately. You can see if I hit stop, and I hit F5 again, the app is up instantly. I don't have to wait for a deploy to a target device, which is hugely beneficial. I can also set breakpoints, step through, do all of the fancy debugging stuff that we all know and love. The next thing that I want to do is I want to work on making sure that my display, that 7219 LED display, does what I want it to. Again, I'd like to not have to deploy to a microcontroller to do that, because I want to make sure it's doing what I want, but without having to do the deploy and debug to a remote device. The nice thing is, Meadow has the desktop, and we have a driver for an I/O expander that allows me to use USB to get SPI functionality. That's done through a WS2812, which I showed just a little bit ago, but I didn't point it out. So let's take a look at that right now. So I had shown you this before, and it's actually already connected up. I just have a breadboard with this FTDI expander on here. This one's an Adafruit, but there are generic versions of it as well. So this is our chip select, power, ground, clock and our data line. And those all just come over to this. This module, basically each one has a controller. And what we've done, and you can't really see, but these pull out, plug back in. Again, I've put 2 red and 2 green in, and this treats this as one display. Now, the really nice thing here is if we use the Meadow Foundation stuff, we can use micrographics, which will turn this into a display that is 8 by 32 pixels. And we can just treat it as a graphical display that is of those dimensions and turn things on and off. Micrographics also has the ability to draw text and draw rectangles and things like that. So that's going to make putting the score on here much easier. In addition to micrographics, we actually have another library called MicroLayout, which gives us controls. If you're familiar with WinForms or really any GUI development, it will be kind of familiar. So what we can do is we can create a label control and put one on the left half and one on the right half, and it has a box control, and we can just, again, make a box that is 8 by 16, put one on the left, one on the right, and fill them. These are color LEDs, but they're single color, so it's really just white is on and black is off. So we can turn on this whole panel here by creating a box and just saying it's visible or not, or this panel here, visible or not. So let's take a look at how that comes together in code. Here again, we have this game display. We had originally done an implementation with the console, but now all we have to do is change that to an implementation that is the 7219. And again, if we take a quick look back here, all I have to do to change between them is this. And now the exact same setup that I was using before uses the 7219 instead of the console. So this really makes debugging and testing this simple. We're doing iterative debugging, iterative testing. We're doing it on the desktop still. I have not touched the microcontroller because I want to get things done as quick as possible, as easy as possible. So I'm going to try to put off getting to the microcontroller till I have to use features of that microcontroller. But again, let's go take a look at this 7219. It's pretty simple. So what we've done is I've got a screen. In MicroLayout language, the screen is the entire display. So we've got the 7219, which is the physical display. Then I've got a screen, which is a logical representation of all of the pixels on the screen. We've got 2 labels, one for the left score, one for the right score. 2 boxes, one for the left, one for the right, that we will show when somebody has scored a touch. Now, what we've done is we create the 7219 and we pass that into the display screen. It's rotated 90 degrees. That's just it's just how the 7219 works. You could have it rotated the other direction, so top to bottom lengthwise for something like, say, Tetris, right? So that is its default layout. This one we're turning it 90 degrees so that it's a horizontal layout. More interesting are the labels. So I've got a label that is half of the screen width, but the screen height. This 1 here is simply because I want it over 1 pixel, not right against the edge. We'll take a look at that here when I run it. But I've got 2 labels. It's basically half the width of the screen starting at the left, and the right label is half the width of the screen starting at the midpoint. And again, the box is really the same. It is a box that is the height of the screen at 0, 0, and then the right box is the same size, but it is over on the right half. So it's half the screen width. The labels, we're going to have the back color be off, so black, and on is Again, white just means turn the LED on because these aren't multicolored displays, or they're not multicolor LEDs anyway. The right label, we want to put the score all the way over on the right so we actually have horizontal alignment here on the label. We don't even have to do any of that calculation. We don't have to do any thinking about that. The box, again, filled is on. We're going to have them visible, false to begin with, so we don't want them displayed. But we do want the labels displayed. So really, it's 2 labels and 2 boxes. The labels are showing for the scores, the boxes are not. When we touch, you can see here, if it's a touch left, we're going to turn the left box on, leave the right box off, and then turn both of the labels off. Touch right is pretty much the same. And then when we show the score, we're going to turn both of the boxes off and show both of the labels. And we're going to set the label text to whatever the current score is. Really, really simple. But take a look at how this works when we run it. So first I'm going to plug this in. It powers up. And this is just, I think, a default state. I don't really know what it's doing here. We haven't told it to display anything, so this is what we get. But let's run the application. Okay, you can see we have gone to 0, 0 for the score. Now, if I use the same keyboard keys, so I push to the right for a touch right, it goes fully red, and now we have 1. To do it again, and now it's at 2. Touch left. Let's test the manual score up and down. So left up and back down, right up, back down. Let's check what happens when we go to double digit. Say, look at that. Now we can hit reset and back to 0. So there we go. We now have the display fully working. Getting this display working was probably less than an hour of work. So I've built a fully functional prototype for this app in roughly 3 hours, maybe 4 hours. And that's starting with I wasn't exactly sure what I was going to do. If I had done some planning ahead of time, it would have been faster, but then you have to count the planning in too. Regardless, we now have a desktop prototype that at least exercises all of our application logic, and it drives some of the more complex hardware, so we're driving the display. Next, I need to port this over to the microcontroller and get that working, but really that should only be wiring up different interrupt ports for these things to work. And here we have the Feather version of the app, so you can see it targets the Feather, whereas before we were targeting Windows. But otherwise, really we just create a different hardware config that is using different pins that equate to these pins here. Otherwise, it's the same all the way down to using a 7219. If you were paying attention, this is slightly different signature than before, and it's only because I moved it into a common library. So both of them now use it and pass in the SPI bus and the chip select. But the code is really the same. And again, then we create the game and we start the game. Create the game and start the game. So really it is identical. And then over here, I've got a lot more wires because this actually needs to get hooked up to hardware buttons. But you can see these two, these are the left and right. So if we make a contact to positive, we have a score. If we use the other one, contact, we get a score. And these are the up and downs. You can see that they work because I'm just plugging pins into a breadboard. We've got some debounce that is happening, or some bounce actually, I guess. But you can see all of these do what you would expect. And then I have the reset here. And that resets back to 0. So all of this works exactly as it did on the desktop. All I had to do was redefine these pins and run some physical wires. The advantage here is that I did most of this development without the microcontroller, so it was much faster, much easier to develop, and only at the end did I wire it up on the Feather itself. Really, the next step is to hook this up with some actual buttons and things like that. So what I'll probably do is either solder up a PCB that this can go into just on some perf board, or maybe even lay out a PCB. Chances are I'll solder up one first and make sure all of that works, and then design an enclosure with Fusion and 3D print it to hold this and get all of the wiring together. Another nice thing about the Feather is it's got this battery connector here, so I can actually take just a standard battery with the right connector and plug it in, and it has both battery operation and the charging circuit. So as long as I design it where I can get to this port, we can plug it in and charge it over USB, and then it will run and charge all internally. So I don't have to do anything other than design a spot for this battery in the enclosure. So that's it. If you're interested in seeing the final product, go ahead and leave a comment down below, and I will maybe do another video once I get it all done. But otherwise, that is it. This is the entire project. Again, a lot of features could be added, things like adding a REST server and things like that to allow you to use a mobile device to interact with it. I may do that at some point, but for now, I need to get this into a box and get it tested on strip with some actual fencers. Thanks for watching.